A pleasant greetings to all. In this video, I am going to explain more than 50 objective questions for the final Anna University theory examination for control system. Go through it. I will give the detailed steps for all the problems also. Unit 1, System and Representation. Under the system, the first topic is basic element in the control system. Open and closed loop system, electrical analogy of mechanical system and thermal system, transfer function, AC and DC servo motor, block diagram reduction and signal flow graphs. Question number 1. Which system is also known as automatic control system? 4 options are given. The open loop system can be modified as closed loop system by providing a feedback. The provision of feedback automatically corrects the changes in the output due to disturbance. Hence, the closed loop system is otherwise known as automatic control system. So this answer, closed loop system, is the correct answer. Next, advantages of open loop system. The first one, simple and economical. Because in an open loop system, not having any feedback element, so it is simple, but it is not accurate and it is not reliable. The first one is the correct answer. Third, which of the following are the disadvantages of closed loop control system? The first one, reduces overall gain, complex and costly due to the feedback element, oscillator response, all the above. See, reduce the overall gain. This is the open loop system. There is no feedback element. And here this is the closed loop system, which consists of feedback element H of S. C of S by R of S is G of S divided by 1 plus G of S into H of S. H of S is 1. So the answer is 10 by 11, 0.909. But see, the gain is 10. So what a great difference between two. So the answer D is the correct one. It reduces the gain. Fourth question. The output of the system has a efficiency has an effect upon input quantity, then the system is. Control system in which output has effect upon the input quantity in order to maintain the desired output value is called closed loop system. So the answer B is the correct one. By using which of the following elements mechanical translation system are obtained? There are 3 elements: mass, spring and dashpot. The answer is all of the above. Then 6th question, force balancing equation of a mass element is, what is the Newton's second law? F is equal to ma. M into acceleration. So it is acceleration d square x by dt square. So the answer is the first one. Which of the following are the advantages of closed loop system? The closed loop system are accurate. The closed loop system are less affected by noise. Both are correct, both 1 and 2. Next question, force balancing equation of dashpot element. In a dashpot, F is equal to B into the velocity. How to write velocity? B into dx by dt. So B is the correct answer. 9th problem, force balancing equation for elastic element is, so what is the force balancing equation? The force equal to K into X. So this is the elastic element. So the answer is The third one is the correct answer. C is the correct answer. Which of the following is our disadvantages of closed loop system? Disadvantages: inaccurate, unreliable. The answer is both 1 and 2. Next question. When a human being tries to approach an object, his brain acts as a controller. Next question. The most commonly used input signal in control system. There are 4 different types of signal: step, ramp, accelerating, then sinusoidal impulse. 5 different types, but the step function is the basic signal in the control system. That is step function. Next one. Which one of the following minimum information necessary to formulate a problem of control system optimization? System state equation is needed, output equation, control vector, and constraints of the problem. So that is D is the correct answer. Next question. Actual input applied to the system in case of closed loop is error signal, actuating signal, controlling signal, none of the above. The actual input is actuating signal. C is the correct answer. Fifth one, the largest error between reference input and the output during transient period. Here this is C of S is 1 is the input, but here this is the response is the output. What is the difference between two is known as largest error. This error is maximum or peak overshoot. Next, transfer function is useful for the study of finding steady state as well as transient response. And next question. The transfer function of a system is the Laplace transformation of impulse response. Next, what is the characteristics of good control system? The good control system is insensitive to parameter variation but sensitive to input commands. That is a good control system. Next question. In a control system, state variables depends on each other. That is the correct answer. Next question. In a control system, excessive bandwidth is not employed because noise is proportional to bandwidth. The bandwidth is increased, proportionate noise is also increased. Next one, that transfer function approach is applicable to only linear time invariant system. Next question, the automatic washing machine is which system? The operation of a washing machine does not depend upon the cleanliness of the clothes. So it is the open loop system. Does not check the cleanliness. Next question, time response of indicating instrument is decided by which of the following systems? So damping system decides the time response of the indicating instrument. So D is the correct answer. Next question, with feedback, transient response decays quickly. When feedback is added, at that time it will reduce the transient response and decays quickly. Next question, dynamic systems are characterized by the change of state with time. Next, the transfer function of the linear system is the ratio of Laplace transform of the output that of input with all the initial condition is 0. So this is the correct answer. Next question, consider the following statement connection with the feedback control system. Feedback can improve the stability or harmful the stability if it is not properly applied. That is the first one. Is the correct answer. In feedback can always improve stability. That is wrong. In many situations, the feedback can reduce the effect of noise and disturbances. That is also correct. In general, sensitivity of the system gain of feedback system to a parameter variation depends upon where the parameter is located. So 1, 3, 4 is the correct answer. Next, Which of the following are the characteristics of the closed loop system? So the first one, it does not compensate for disturbance. Wrong. It reduces sensitivity of the planned parameter variation is correct. Then it does not involve output measurement. Wrong. It has the ability to control the system transient response. So second and fourth are the correct answers. Next, in a closed loop control system, control action depends on the output because feedback is employed in closed loop control system. Consider the following statement regarding advantages of the closed loop negative feedback control system over open loop system. The first one, overall reliability of the closed loop system is more than the open loop system. That is correct. Reliability is more. Then second one, transient response in the closed loop system decays more quickly than the open loop system. Also correct. Then the third one, in open loop system, closing of the loop increases the overall gain. Wrong. In the closed loop system, the effect of variation of component parameter on its performance is reduced. In a closed loop system, component parameter and the performance is reduced, which that is also correct. So 1 to 4 is the correct answer. Next, which one of the following effects in the system not caused by negative feedback? That is increase in distortion is the correct answer because gain is reduced, output impedance also reduced, bandwidth is increased, but increase in distortion is not occurred. That is the correct answer. The next question, with negative feedback, the system stability and system gain. The system stability, the negative feedback increases, but system gain is decreases. B is the correct answer. Next, feedback control system are less sensitive to forward path parameter changes than to feedback path parameter changes. This one is the correct answer, C. When deriving the transfer function of the linear element, initial conditions are assumed to be 0 and the element is assumed to be not loaded. That is the correct answer. Next question. The open loop transfer function of the unity feedback system G of S equal to 1 by S plus 2 the whole square is given. The closed loop transfer function will have pole set. So this is the open loop transfer function. From the open loop transfer function, first of all, I am going to find out the closed loop transfer function. So what is the closed loop? TF equal to G of S divided by 1 plus G of S in the H of S. Next, I have to apply the value here. After the application of the value, I will reduce it. So 1 by S plus 2 the whole square divided by 1 plus 1 by S plus 2 the whole square into 1. H of S is 1. Then 1 by S plus 2 the whole square the whole divided by, have to take LCM here, S plus 2 the whole square plus 1 divided by S plus 2 the whole square. Now both denominator get cancelled. Finally I get 1 by S square. Have to expand this term using the formula S square plus 4S plus 4. So plus 1 S square plus 4S plus 5. And next I am going to apply the formula to find the root minus B plus or minus square root of B square minus 4AC by 2A. Here minus B, that is minus 4 plus or minus 4 square minus 20. So minus 4 plus or minus 2I divided by 2. So minus 2 plus or minus J, that is the correct answer. So minus 2 plus or minus J. So this is the correct answer. Next problem. The transfer function has 0 on the right half of the S-plane, the function. Normally, all the poles in the left half of the S-plane, we can say that the stable system, but this is the unstable system, otherwise known as non-minimum phase. Here pole is in the pole is in left half and 0 is in right half, so we can say that non-minimum phase system. And the next problem, the transfer function of the low pass RC network is, Here, this is the low pass RC network. So in a low pass RC network, first resistance is connected, then capacitance is connected, and afterwards I have to apply the nodal analysis here. This node, the voltage is V0 by V0 of S. So I have to apply the nodal analysis. V0 of S minus VA of S divided by R plus V0 of S divided by 1 by Cs, that is in the Laplace transformation, that is equal to 0. So V0 of S, take it outside, 1 by R plus Cs equal to VI by R. Then V0, take LCM here, V0 of 1 plus RCS divided by R equal to VI by R. Both the R's get cancelled. V0 of S divided by VI of S is 1 by 1 plus RCS. And next problem, the transfer function of the circuit is shown in figure. That is also a low pass filter. The formula is 1 by 1 plus SRC. Okay, next I am going to explain the transfer function C by R of the system shown in figure. So how to find out the transfer function? See here, the first one is the feedback loop, first feedback loop, and here this is the second feedback loop. So first feedback loop, I am going to reduce it. First feedback loop is reduced first. So what is the formula? And second feedback loop I am going to reduce. The formula is 1 plus G of S divided by 1 plus G of S into H of S. So G1 divided by 1 plus G1 into H1, G2 divided by 1 plus G2 into H2. Finally, both the blocks are connected in series. If both are connected in series, so I have to multiply both. So G1 G2 divided by 1 plus G1 H1 into 1 plus G2 H2. Now I am going to expand this. So 1 plus G1 H1 plus G2 H2 plus G1 G2 H1 H2. So that is the answer. So D is the correct answer for this problem. Our next problem, for the block diagram shown in figure, the overall transfer function C by R. So first they see this block diagram. Here we are having the takeoff point. The first step, you have to move the takeoff point in this point, the output side. Then you have to reduce that. So I have to move the takeoff point. Here how to move the takeoff point? Here 1 by G2 is added in the feedback block H1. In this way, I have to move the takeoff point to the output side. After finishing this, see here, this is the first block I am going to reduce. So this is the positive feedback loop, G2 divided by 1 minus G2 H2. It is connected in series with G1, and H1 and G1 by G2 are connected in series. Both are multiplied together. Now what I have to do, I am going to reduce this, reduce the first these two blocks. Both are connected in series now. So I am going to reduce this block. So I am going to reduce these two blocks. Both are multiplied together first, and afterwards it is the negative feedback loop. Next I am going to reduce the negative feedback loop. G1 G2 divided by 1 minus G2 H2, the whole divided by 1 plus G1 G2 divided by 1 minus G2 H2 into H1 by G2. G2 get cancelled. So G1 G2, these two denominator get cancelled, and 1 minus G2 H2. Okay, take LCM plus G1 H1. That is the answer. Next, the characteristic polynomial of a system can be defined as T of S is equal to N of S divided by D of S. N of S is the numerator polynomial, D of S is the denominator polynomial for the closed loop system. Denominator polynomial of the closed loop system is 0. That is known as characteristic equation of the polynomial. Next, the transfer function of the network is shown in figure, and how you have to find out the E0 of S divided by EA of S. So for finding out E0 of S divided by EA of S, first of all I am going to mark the nodes B and E0. So I am going to mark the nodes here. After finishing this, what I have to do? So after finishing this, I am going to write the equation. Apply nodal analysis for the corresponding node B. And how to write the equation? V minus EI divided by R plus P divided by 1 by Cs plus V minus E naught divided by R equal to 0. Next, what I have to do? I have to separate V and EI and E naught. So take V outside. So V of 1 by R plus 1 by Cs, that is Cs, again 1 by R, that is equal to EI by R plus E naught by R. Next V, and I am going to find out the LCM. So 2 here, 2 by R plus RCS divided by R. Here EI plus E naught divided by R get cancelled. So V of 2 plus RCS equal to EI by E naught, EI plus E naught. And next what I am going to do, I am going to take the second equation here. Here I am going to apply the nodal analysis. So E naught minus V by R plus E naught divided by 1 by Cs. Okay, this is the second one, that is equal to 0. Now I am going to take E naught outside. So E naught of 1 by R plus Cs equal to V by R. So E naught of 1 plus RCS equal to V. Now I got two equations. One of the equation is V of 2 plus RCS EI plus E naught. Second equation, E naught of 1 plus RCS equal to V. Now what I have to do, I am going to substitute V in the equation 3. Okay, so I'll get the answer E naught into 1 plus SRC into 2 plus SRC equal to E naught plus EA. Now I am going to expand this E naught of 2 plus 2 RCS plus RCS plus RCS the whole square, that is equal to E naught plus EA. Then E naught of 2 plus 3s RC plus RC the whole square and S square equal to E naught plus EI. Now E naught come this side, that is the LHS. So E naught of S square into RC square, you have to write it first, and second you have to write 3s RC plus 1 minus plus 2 minus 1, no, so plus 1, that is equal to EI. Now what is RC? Tau is equal to RC. Tau is the time constant, so time constant equal to RC. So instead of RC you have to put tau. So S square into tau square plus 3s into tau plus 1. So this is the correct answer. So which option? That is the option, this option number B. That is the correct answer. Next I am going to explain the next problem. Let a casual LTA system be characterized by the following differential equation with initial rest condition. The initial condition is 0. So first of all, I am going to apply the Laplace transform for this equation. So S square into Y of S, all the initial conditions are 0, plus 7S into Y of S plus 10 into Y of S equal to 4x of S, 4 into x of S plus here 5 into S into x of S. Have to take Y of S outside. So Y of S is S square plus 7S plus 10. That is equal to 4 plus 5S into x of S. So what is Y of S by x of S? So Y of S by x of S, that is equal to 4 by 5 plus 4 plus 5s the whole divided by S square plus 7s plus 10. Now I am going to rewrite this 5s plus 4 divided by, I have to divide this S plus 5 into S plus 2. Next I am going to apply the partial fraction, have to divide it A by x plus 5, B by S plus 2. Okay, now you have to consider these equations and multiply both sides by S plus 5 into S plus 2. 5 into S plus 2. So LHS we are having 5s plus 4. In RHS we are having a into s plus 2 plus b into s plus 5. So put s is equal to minus 2. So the answer is 5 into minus 2 minus 10. So minus 6 equal to 5 plus minus 2. This term is 0. So b into 5 minus 2. So that is 3b. b is equal to minus 2. This is the first answer. And the second answer, put s is equal to minus 5. And 5 into 5, that is minus 25 plus 4, that is equal to a into minus 5 plus 2, that is minus 3. So minus 21 equal to minus 3a. So a is equal to 7. So both answers are find out. Finally, I have to substitute this in this equation. So what is the y of s? Y of s divided by x of s, that is equal to what? That is a is equal to 7. 7 by s plus 5 plus minus 2 by s plus 2. So what is the correct answer? The correct answer may be, so I have to take the inverse Laplace transformation now. So 7 into 1 by s plus 5 is e power minus 5t minus 2 into e power minus 2t is the correct answer. Next problem. The transfer function of the system is described by d square y by dt square plus dy by dt equal to du by dt plus 2u. U as the input and y as the output. Okay, first of all, I am going to apply the Laplace transformation on both sides of the equation with 0 initial condition. So s square into y of s and s into y of s equal to s into u of s plus 2 into 2 into u of s. Now I have to take y of s outside. So inside I am having s square plus s, and here I am having s plus 2 into u of s. Now I am going to find out output by input, that is the transfer function. So what is the answer? S plus 2 divided by s square plus s is the correct answer. So option A is the correct answer. Our next problem, select the correct transfer function v naught of s divided by vi of s from the following. So here also I am going to mark the node V. I am going to apply the nodal analysis. Here all the currents are flowing away from the junction. This is my assumption. Now I am going to apply the nodal analysis in the corresponding node V0, nodal analysis. So V0 minus Vi divided by 1 plus V0 by 1 plus V0 by S, that is equal to 0. Take V0 outside. 1 plus 1 plus 1 by S, that is equal to Vi by 1. Okay, in the next one, how to find out V0 of 2 plus 1 by S equal to Vi. So V0 of 2S plus 1 by S, take LCM, that is equal to Vi. Our next question, next answer, V0 by Vi equal to S by 2S plus 1. So S by 2S plus 1 is the correct answer. So option C is the correct answer. Next problem, the transfer function for the diagram is shown below is given given by which one of the following. So C and R. So this is the high pass filter. The previously we have seen the low pass filter. This is the high pass filter. Here also I am going to apply the value. Here output is V0 and input is Vi. Apply the nodal analysis here. So V0 minus Vi by 1 by Cs plus V0 by R equal to 0. What is the second one? So take V0 outside, Cs plus 1 by R, that is equal to Vi into Cs. Okay, next one, V0 take LCM, R plus Cs by R equal to Cs into Vi. Now what is V naught by Vi? That is equal to cross multiply this RCS divided by R plus RCS divided by 1 plus is V naught into RCS plus 1. So 1 plus RCS is the correct answer. Next problem, as shown in figure, a negative feedback system has an amplifier of gain 100 with plus or minus 10 tolerance in the forward path and the attenuator value of 9 by 100 in the feedback path. The overall system gain. Okay, first G is given, forward path gain is given. So G is equal to what? 100 plus or minus 10%. So this value 100 into 10 by 100. So that is 10%, 100 plus or minus 10%, so 10. So the G may be 100 plus 10 or 100 minus 10. So what is the value? G may be 110 or 90. Okay, now we are going to find out for 110 and next for 90. This is a negative feedback loop. So what is the transfer function for 110? So 110 is the first one. So 110 divided by 1 plus 110 and h of is equal to 9 by 10. Here 9 by is 9 by 100. So 9 by 100. Cancel. So 110 divided by 99 by 10, 9.9. So 10.9. So what is the value? 110. I have to use the calculator here to find out. 110 divided by 10.9. So that is equal to what? 10.091. Can we write the 10.091 as 10.1? So what is 10.1? So 10 plus or minus 10%. Can we write like this? 10 plus 10%. Okay, 10 not plus or minus 10 plus 10%. Okay, I have to rub it. So 10 plus 10%. And next, in the similar manner, I am going to use 90 as the forward path gain now. So T of S is equal to 90 divided by 1 plus 90 into 9 by 100. Okay, cancel. 9 9s are 81. So 8.1 plus 1, 90 by 9.1. So what is the value T of S now? I am going to find out using the calculator. So 90 by 9.1, the 90 by 9.1. So that answer is here 90, yes, 81, 90 plus 9.1. Okay, the answer is 9.89. Okay, here 90, 110, 90, 1 plus 99, 9s are 81, 8.1, 9.1. So that is 9.89. So 9.89. So how to write this 9.89? 9.89 can we write like this? 10 minus 10%. Okay, 10 minus 10%. So overall value is 10 plus or minus 10% is the correct answer. Okay, next problem. The input-output relationship of the linear time invariant continuous time system is given by R of t equal to d square c of t plus divided by dt square plus 3 into dc of t divided by dt plus 2c of t. Okay, here you have to find out, apply the Laplace transformation here. So apply the Laplace transform. So what is the answer? The first one is s square into c of s. Second one 3s into c of s plus 2 into c of s equal to r of s. Okay, what is the c of s by r of s is what? C of S by R of S is 1 divided by S square plus 3S plus 2 is the correct answer. B is the correct answer. And next I am going to explain if the relationship between input u of t and output y of t to be. Here this is the convolution and I am going to write the expansion. I am going to write like this: y of t is equal to 2 plus t star e power minus 3t. Next I am going to find out the Laplace transformation. Apply the Laplace transformation here. So y of t equal to expand this e power minus 3t plus t into e power minus 3t. So what is the Laplace transformation of e power minus 3t, that is s plus 3, and here what is the value? 1 by s plus 3 the whole square. Now I am going to take the LCM. So s plus 3 the whole square, s plus 3 the whole square, here 2 into s plus 3 plus s plus 3. So what is the answer to s plus s? 2 into s plus 3. So the answer is s, not s plus 3. Here is taking LCM, here is 1 only. So 2s plus 4 divided by s plus 3 the whole square is the correct answer. So the option, 2s plus 3, 6, so 7. So this is the correct answer. Okay, next, the sensitivity of the overall transfer function m of s of a closed loop system with respect to forward path gain. First we have to, I am going to write the formula for sensitivity. So that is dou g by g divided by dou m by m. Okay. Here it is wrong. Yes. M to g. So dou m divided by m, dou g divided by g. So how to write this? G by m into dou m by dou g. So first of all, what is m? M is equal to closed loop transfer function 1 plus gh. Okay, now I am going to take apply the differentiation with respect to g. So dou m by dou g is 1 plus gh into 1 minus, or I am going to put h is equal to 1 here. So 1 plus g into 1, then g into 1 divided by 1 plus g the whole square. So 1 by 1 plus g the whole square. Okay, and next g by m. So what is m? M is equal to g into 1 plus g h, and dou m by dou g is 1 by here g by m. So this is 1 plus gh, and here 1 plus gh the whole square. Cancel, g cancel. Finally I get 1 plus 1 plus gh. So this is the correct answer. Then consider the block diagram. See here the answer. Which of the block diagrams can be reduced to the transfer function? See the first block diagram, G1 and G2. Here this is the feedback path. Okay, negative feedback. It is wrong. So this is forward positive feedback. The expansion is G1 by 1 minus G1 G2. This is correct. So 2 is correct. And here also negative, wrong. And this is correct. G1 G2 divided by 1 minus G1 G2. Okay, G1 G2 divided by 1 minus G1 G2. The blocks are combined series, so G1 by 1 minus G1 G2, 1 minus G1 G2. So 2 and 4 are the correct answer. This is wrong. 2 and 4 are the correct answer. Next, what is the overall transfer function of the block diagram shown in figure C? G1, G3, it is connected to the positive terminal. Okay, so this is the parallel blocks, not feedback block. This is the parallel block. Now, first of all, I am going to reduce the parallel block. So, G1 plus G3. Next, see G2, and this is the negative, negative into positive, again negative. So, this is the negative feedback. So, this is the parallel block, the first one. This is connected, the negative feedback. So, negative feedback is what? G2 divided by 1 plus G2 H1. Now, both the blocks are connected in series. Here, this is R of S and this one is C of S. Both are connected in series. So, now what is C of S divided by R of S? That is equal to G2 into G1 plus G2 into G3 divided by 1 plus G2H1. Okay, G2H1. This is the correct answer. So, option A is the correct answer. And next, I am going to explain the last one problem. Consider the following 3 block diagram ABC shown in figure. And one of the block following statement is correct respect to above block diagram. A, B, C are equal, and that is the correct answer. So you have to first of all, what you have to do, you have to multiply this block, and then you have to reduce the feedback loop, and this block is over. And here, this is the one that is the takeoff point. Move the takeoff